Let's practice converting rates together. In each of these practice problems, we're going to start out by using an equivalent unit conversion, followed by using the identity property of multiplication, so essentially multiplying each of these units or rates by 1, and then we're going to make sure we round to the nearest thousandths place for our answer, just so we're consistent. All right, for number 1, we have this 100 meters per 9 seconds, so I'm going to just start by writing that down. I'm going to use M to abbreviate meters, and I'm going to use SEC for seconds, so I'm going to have 100 meters per 9 of these seconds. That's what we're going to start with here. Now our goal is to turn this meters per second into miles per hour, so let's go ahead and start by converting the time first, and then I'll do the distance second. So let's start with time here. So to begin with time, I know there's going to be 60 seconds in a minute. Let's put the 60 seconds on top because we want it to cross cancel. We'll put 1 minute on the bottom here. So remember, this is just equal to 1. So if we go ahead and multiply these, we're going to see that the seconds are going to cross cancel. So we're going to get meters per minute, but let's keep on going from there. Next, we want to get the minutes to hours. So let's go ahead and put that there are 60 minutes in 1 hour. So put the 60 minutes on top and put the 1 hour on bottom. Now putting the minutes specifically on top, this is going to cross cancel with the minutes on bottom here. So if we were to stop, we would have meters per hour. So we're getting closer to what we want. Now we just have to take care of the distance. So how many meters are in a mile or how many miles are in a meter? Let's go ahead and look that up if you're not sure. But I'm going to go ahead and say, well, I know there's going to be 1 mile. I'm going to put that on top because we want miles. And then on bottom, we're going to put 1,609.34 meters. So that's something you can go ahead and look up for a conversion. Alrighty, so by putting the meters on bottom, this meters and this meters are going to cross cancel with each other. Each of these represent 1 since they are the same value over itself. So that's always going to be 1. So we're just using the identity property of multiplication, and these are all different types of unit conversions. Now, throwing this into a calculator, what we're going to do here is multiply this 100 by 60 by 60 by 1 for the numerator. Notice we just have some units of miles on top. So if we multiply that, go ahead and pause if you need to put that into a calculator. But you should get 360,000. Okay, that's going to be on top. And I think miles is going to be our units that we have left up there, which is what we were aiming for. And then in the denominator, if you multiply 9 times this 1 times 1 times 1,609.34, we will then get this 14,484. Again, just plug that into a calculator, 0.06. And that's going to be in hours here. Okay, so we do have miles per hour. However, we'd like to go ahead and get it per 1 hour. So let's go ahead and simplify this just a little bit more. What I'm going to do here is to get a unit rate of per 1 hour, we must divide by 14,484.06. And if we do that to the bottom, let's go ahead and do that to the top. Now, if we do that, of course, on bottom, we're just going to get per 1 hour. So 1 HR or 1 hour here. And on the top, go ahead and type that in. Pause if you need to. And to the nearest hundredths place, we're going to get about 24.85. Now, remember, our units for the top is going to be miles. So this is going to be about 24.85 or a little less than 25 miles per hour. So for this particular problem, we can say this is about 24.85 miles per hour, or mph. Let's check out number 2. For number 2, we're starting off with 45 miles per hour. So let's put 45 mi for miles per 1 hour. I'm going to put 1 hr in the denominator. And we're going to go ahead and multiply this by some of our unit conversions and use the identity property to convert this to feet per minute. Okay, so let's go ahead and deal with time first, just because I think that's a little bit easier. Now going to minutes is not too bad. So we have 1 hour on bottom, so let's go ahead and put 1 hour on top so we can cross cancel that. And this is going to be 60 minutes. So I'm going to put 60 min for minutes. Now remember, we are using the identity property of multiplication here, which states that we can multiply something by 1. That did not change its value. And we strategically put this hours and hours on top and bottom here so that we could cross cancel them. Okay, so if we were to stop now, we would have miles per minute, where we are kind of going in the right direction here. We already have the minutes we want, so I think we just need to turn the miles into feet. Okay, so let's do one more over here. We have miles on top, so I'm going to put miles on bottom. So I'm going to put 1 mile on bottom, and go ahead and look it up if you're not sure how many feet are in a mile. But I know it's going to be 5,280 feet. That's going to be in 1 mile. Now this right here is another value of 1 because it's a unit conversion here. Again, notice how we are going to be able to cross out the miles and miles. They're diagonal from each other. And the only units we're left here are going to be feet per minute, which is what we were looking for. All right, at this point, it's time to plug this into a calculator. If we go ahead and do that, multiplying this 45 by 1 by 5,280, that is going to end up being, what is that? It's going to be 237, and then it's going to be 600. So this is going to be 237,600 feet. And let's see what's going to be on bottom here. Looks like we just have 1 times 60 times 1, so that's going to be 60. Okay, and now you can cross cancel and stuff like that, but again, if you have a calculator, you can just go ahead and just divide here, and this is going to be minutes on bottom, right? So we have feet per minute, which is what we were looking for. Now to get this to be a unit rate, let's go ahead and divide top and bottom both by 60, so we can get this to feet per 1 minute. So if we do that on the bottom, we will end up with 1 minute, right? And on the top, this 237,600 divided by 60 is going to equal 3,960, and that's going to be feet. Now that we have a rate per 1 minute, we know that if you're going 45 miles an hour, that is equivalent to going 3,960 feet per minute. Here's number 3. For number 3, we have 12 gallons per minute. So we're going to go ahead and put 12, and I'll put GAL for gallons. And I'm going to put this on top of 1 minute. So it's kind of nice. It's just 1. It's not too bad. Let's go ahead and see what we got to multiply this by to get our quarts per hour. Okay, so I'm going to go with time first just because that's a little bit more familiar to me. And for minutes, I'm going to go ahead and say there's 60 minutes in 1 hour. So 60 minutes is the same thing as 1 hour. Put those on top of each other, but make sure you put minutes on top. Now, when we do this, notice that the minutes and minutes are going to cross cancel as we planned. If we stop, we're going to have gallons per hour, but we want quarts per hour. So let's go ahead and look up how many quarts there are in a gallon. Now, hopefully you know that there are going to be 4 quarts in a gallon. I'm going to put the 1 gallon on the bottom because I want it to cross cancel. And there's going to be 4 quarts there, so I'm going to put 4 QTS or 4 quarts. It doesn't matter if you put the S or not there, it's the same idea. And so you can notice here that because we put gallons on bottom, that can cross cancel with the gallons on top. So we're going to have quarts per hour, which is what we were looking for. So we're all done with kind of setting up our problem here. Now it's time to go ahead and use a calculator. What we're going to do is multiply this 12 by 60 by 4. If we multiply 12 by 60 by 4, that's going to equal this 2,880. And we just have quarts on top, so I'm going to put QTS for quarts. And then on the denominator, or the bottom part here, we have 1 times 1 hour times 1. So that's all just ones. So that's going to be per 1 hour. So this one's actually kind of nice because we are basically done here because it's already a unit rate and it's already per 1 hour. So if you were filling up some sort of fish tank or something with 12 gallons every minute, that is the same thing as filling it with 2,880 quarts every hour. Here's number 4. So for this one, we're going to be starting off with 8 liters per day. So I'm going to put an 8 with an L for liters. That's going to be in 1 day. I'm going to put 1 and put a capital D. Hopefully that makes sense to you. Now let's go ahead and take this and multiply it by some conversion factor to start with, so we can convert this to gallons per minute. Okay, so let's go ahead and start off with time first. So for 1 day, I'm going to put 1D up here for 1 day. That's going to be 24 hours. Okay, that's going to be the first conversion factor I'm going to use. Now again, this is equal to 1, so we can go ahead and cross cancel the D's when we multiply here, and we're not changing the value because that's just equal to 1, so that's the identity property. If we stop here, we're going to have liters per hour, but we want this gallons per minute. So let's go ahead and change the hours maybe to minutes now. So I'm going to put 1 hour on top, and we're going to go ahead and put 60 minutes on bottom. All right, so setting up like this, we can take the hours and cancel those out. If we were to stop, we would get liters per minute. So we're getting closer here, but we need to somehow get these liters to gallons. So if you need to look it up, go ahead and please do so. If we have liters on top in the problem, I'm going to go ahead and put liters on the bottom. So if you find out how many liters are in a gallon, you can hopefully find that 1 gallon is approximately equal to 7 and then 8 and then 5. That's a pretty good rounding over there to the thousands place. So 1 gallon is about 3.785 liters. And so if we go ahead and set it up like this, all these liters are going to cancel out. So we're just going to be left with gallons per minute, which is what we are looking for, okay? So keep in mind, again, this ratio here is equal to 1, this is equal to 1, and this is equal to 1. So taking our original value, multiplying it by 3 ones is using that multiplication identity property, so we're not going to be changing the value, okay? Now it's time to plug this whole thing into a calculator. So let's multiply in a calculator the numerator. So we have 8 times 1 times 1 times 1. So the numerator is actually quite easy, probably don't need a calculator. It's going to be 8 gallons. And on the bottom, if we multiply 1 by 24 by 60 by this 3.785, we're going to get approximately over here this 5,450.4, and that's going to be minutes. All right, now to get this to be a unit rate, so to get a 1 on bottom, let's go ahead and divide by 5,450.4. If we do it on the bottom, we should do it on top, so divide by 5,450.4. If we go ahead and do so, I should really be using these approximation symbols here. So if it's not equal, we did some rounding. On the bottom, we should be getting 1 minute because we need a unit rate, and that's what we're doing here. Now on top, go ahead and take 8 and divide that by this 5,450.4 in a calculator, and you should get something like 0.0015 roughly, and that's going to be gallons per minute. Okay, so I know the directions do say to go to the hundredths place here. So if we were to do that, you're basically saying that you would be filling 0 gallons per minute, right? So I think in this case, even though it says to go to the hundredths place, I think it's more appropriate to keep this a little bit more precise and go to the thousands or 10,000s place here so you know what's going on. Another way of writing this, we could say this is going to be 0.0015 or 15 10 thousandths gallon per minute. Here's number 5. In number 5, we're going to be starting with 130 miles per hour. So 130 miles, and that's in 1 hour. Put 1 HR on bottom, 130 MI on top. And we're going to go ahead and multiply this by some unit rate conversions and see if we can turn this into kilometers per minute. Okay, so we just have to go from hours to minutes. I'm going to do that one first, get it out of the way. So we have hours on bottom, so I'm going to put 1 hour on top, and that's equivalent to 60 minutes. So I'll go ahead and put 60 MIN on bottom. Again, this is just equal to 1, so we're using that identity property here. We do this because then we can get these hours to cross cancel here, and then we're just going to be left with miles per minute. Now we just need the miles to turn into kilometers, so let's go ahead and use one more of these conversion factors. Okay, so we have miles on top, so we're going to put miles on bottom here. So I'm going to go ahead and put 1 mile on the bottom part of this rate, and that's equivalent to about 1.609. I think that's accurate enough, and I'm going to make that kilometers, right? So there's about 1.609 kilometers per 1 mile. All right, so now that you have this down, this miles and miles will cross cancel. So the only units we have here are going to be kilometers per minute, which is what we are looking for. Again, both of these unit conversion factors are just equal to 1. So using that identity property of multiplication, we're not really changing the value here. We're just getting an equivalent one. So let's go ahead and put a squiggly equal sign here. Again, if I haven't done that in the past, just you can go ahead and do so as well, because we know we're rounding a little bit. It's just more accurate. All right, so on top, if we take this 130, multiply it by 1, and multiply it by this 1.609, we should get something like 209.17, and that's going to be in kilometers. And what about underneath that? Well, underneath we just have 1 times 60 times 1. That is going to equal 60, so that's going to be 60 MIN for minutes. Okay, so we have kilometers per minute, but we would like it per 1 minute instead of 60 minutes. So we can do a little divide by 60 divided by 60 here. If we do that, we're going to end up with just 1 minute on the bottom, 1 minute on the bottom. And what's this 209.17 divided by 60? Again, go ahead and take some time to put that into a calculator and round to the nearest hundredths place. We should round this to about 3.4. I think that 6 is going to bump that 8 up to a 9, so 3.49, and that's going to be kilometers per 1 minute. If you were going at 130 miles per hour, that would be equivalent or the same thing as going about 3.49 kilometers every minute. For number 6, let's start off with 42 of these gallons per hour. So 42, I'm going to use GAL to abbreviate gallons. That's per 1 hour. I'm going to put 1 hour on the bottom here. And let's start multiplying it by some unit conversions to get this into liters per minute. Okay, so let's start with time first. So hours into minutes, not too bad. Let's go ahead and put 1 hour on top and put the 60 minutes on bottom. Now this 1 hour and 60 minutes, if we put that on top of each other, that's just equal to 1, and these hours can cross cancel. If we stop here, we'll have gallons per minute, which is along the way of what we're trying to do, but we need liters per minute, so we need to multiply by one more unit conversion here. Okay, so let's see how many liters are in a gallon. I think we've done this earlier, so you can go ahead and take a look at that and try and look at it or look it up again. Now our gallons is on top, so let's go ahead and put our new gallons on bottom. So 1 gallon is about 785. That's going to be liters. Okay. So if we go ahead and multiply by this unit conversion factor, which is just equal to 1, we're going to be able to see that the gallons and gallons are going to cross cancel with each other. So the only units we're going to have are going to be liters per minute, which is exactly what we want. So now when you multiply 42 by 1 by this 3.785 liters, that's going to end up being 158.97 liters. That's going to be on top of what? Well, on the bottom, looks like we have 1 times 60 times 1. That's just going to be 60, so it's going to be 60 minutes. Okay. What we're going to do next is we want a unit rate per just 1 minute, so we're going to divide top and bottom both by 60. If we go ahead and do that, then the bottom here is just going to be 1 minute. And then on top, if we take 158.97 and divide that by 60, that is going to be, let's see, that's going to be 2.6, let's go ahead and write 2.6495. So I'm going to go 2.65. That 9 is going to bump that 4 up, and that's going to be liters per minute. So if we were maybe filling up a swimming pool at a rate of 42 gallons per hour, this would be equivalent to filling it up at a rate of 2.65 liters per minute. Here's number 7. For number 7, if we have 45 inches per second, let's go ahead and write that down. 45, I use IN for inches, and this is just going to be in 1 second, and I'll put SEC for seconds. Let's go ahead and start by multiplying by unit conversion to convert this to meters per day. Okay, I'm going to start with time first here, so let's go ahead and multiply this. We have seconds on bottom, so we know there's going to be 60 seconds. That's going to be in 1 minute. Let's go ahead and write that first unit conversion down. If we do that, then the seconds here are going to cross cancel nicely. Then we want to go from minutes to hours. So let's go ahead and take the minutes. Let's put 60 minutes on top so we can cross cancel them. That's going to be in 1 hour. So put 1 hour on bottom. This minutes and this minutes will cross cancel nicely. So right now we have inches per hour, but we want it per day. So let's go ahead and say that there are 24 hours. Go ahead and put 24 hours on top, and that's going to be in 1 day. So I'm going to put 1 D. I think I used D earlier for day, so I'll use it again here. At this point, you can see that the hours and hours here will cross cancel as well. So we have inches per day, which is pretty good because we want the day, but we don't want inches. So we have to somehow get inches to meters now. Now, before we can go from inches to meters, I think a good stop along the way is to go from inches to centimeters. So if we have inches on top, let's go ahead and put 1 inch on bottom. So 1 inch is about 2.54 centimeters. So I'm going to put 2.54 cm to turn this into centimeters. Now if we do that, we can see these inches are going to cross cancel nicely. So we are going to have this centimeters per day, but how do we go to meters? Well, for one more conversion here, let's go ahead and multiply. There are going to be 100 centimeters in 1 meter. So let's put 1 meter on top and 100 centimeters on bottom. Alrighty, so the centimeters and centimeters will cross cancel here nicely. And so we just have meters per day, which is exactly what we were looking for. Okay, so I know that was a lot. Let's go ahead and put an approximation sign here. And let's just go ahead and start by multiplying the tops and the bottoms. All right, so there's a lot going on top here. 45 times 60 times 60 times 24 times 2.54 times 1. If we plug that into a calculator, I'm getting that's about 98755
to 0, and the units are going to be meters. Okay, so that's going to be 9,875,520, and that's going to be meters. And on the bottom, what do we have? Just 1 times 1 times 1 times 1 times 1 times 100. Okay, so this is going to be 100 on the bottom, and that's going to be in days. So I'm going to put a D for days, or you can just write out the word days if you would like to. Okay, so next we're going to go ahead and divide this by 100 and this by 100. So we don't want per 100 days, we want per 1 day here. If we do that, we're just going to end up with 1 day on bottom. And on top, you don't need a calculator, just dividing this by 100. You take the decimal that's here at the end and move it to the left 2 times. That's 100 times smaller. So that will be, what, let's put 9,875, 5, and that's going to be 0.2. Okay, that's going to be meters per day. So if something was moving at a rate of 45 inches per second, that would be equivalent to moving 98,755.2 meters per day, roughly. Alrighty, here's one final example. In number 8, let's go ahead and try. We have 38 kilograms per 1 day. So let's start by writing 38 kg or 38 kilograms. That's going to be in 1 day. Put 1D. And let's go ahead and see. Let's multiply this by some unit conversion to eventually get this over to pounds per hour. Okay, now I'm going to go ahead and start with dealing with the time. Again, I feel most comfortable with that. So for 1 day, how many hours are there? I'm going to put 1 day on top here and then 24 hours on bottom because there's 24 hours in a day. Now this is the identity property here, and we can see that the days and days are diagonal, so they can cross cancel. If we stop, we'll have kilograms per hour, so the time is good. We just want the kilograms to convert to pounds. So what's another conversion factor we can use here? We need to know how many kilograms are in a pound or how many pounds are in a kilogram. Alrighty, so you can either go ahead and memorize the first few digits, or you can look it up in a table here. So let's see, we need kilograms on bottom here. So I'm gonna say that 1 pound is gonna go on top. 1 lb represents 1 pound. And if for kilograms, that's roughly 0.45, what should I round this to? I'll try to be as accurate as possible, 454. So I'll go to the thousands place, and this is gonna be kilograms for every pound. Alrighty, so because we put kilograms on bottom, these kilograms and kilograms can cross cancel nicely, and we can go ahead and start just putting this into a calculator and multiplying the tops and bottoms. Okay, now on top we're just gonna have 38, this 38 multiplied by 1 and 1. If we go ahead and do that, that's just going to be 38, and we're gonna have the units of pounds, so let's put LB. Okay, if you put LBS for pounds, that's fine too. And on the bottom, let's just go ahead and multiply 1 times 24 times 0.454, that approximated value for kilograms. And that's going to end up being about 10.896 hours, okay? And so we don't really want per this many awkward amounts of hours, so let's go ahead and get it per 1 hour. So let's go ahead and divide by 10.896. If we do it on bottom, let's go ahead and do it on top, 10.896. If we do that, then we're just going to get per 1 hour, which is really the goal here, per 1 hour on the bottom. And if we take 38 and divide that by that 10.896 on top, that's going to be roughly 3.487, but a 7 tells the 8 to go up to a 9. So about 3.49, and that's going to be pounds per hour. So maybe if some animal ate 38 kilograms of some sort of plant or food per day, that would be equivalent to 3.49 pounds per hour, which is a lot of food. So there you have 8 different examples of converting rates to different types of units. If you found the video helpful, please consider giving a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I hope to see you in the next one.